Assalamu alaikum, dear students. Today we shall talk about the ozonolysis of alkene. As you know, we have studied different types of the oxidation using different oxidizing agents. Today we shall discuss the oxidation using ozone. Lysis means breaking, so breaking with the help of ozone. So what happens actually in this reaction? The olefins, whenever they are reacted with ozone, followed by the reduction using dimethyl sulfide or any other reducing agent, so we get carbonyl compounds. What is it? It's a cyclohexene, and these are diol hexane 1,6 hexane diol 1,6 hexane diol, so dicarbonyl compound. So what happens in this reaction, that whenever they are unsaturated hydrocarbons, especially alkenes, they are made to react with ozone. The olefinic double bond, it ruptures right from the middle, and each bonded carbon has been converted into carbonyl carbon. I draw another example using the same reagent, ozone and dimethyl sulfide or zinc HCl. In the first step, there will be the reaction of ozone followed by the reduction using different reducing agents. So you will have to recognize where is the double bond. Here is the double bond, and here will be the reaction. So carbon carbon double bond. Ozone will break this carbon carbon double bond, and each carbon will be converted into carbonyl group. So we will get two products here. The first one is this, and the second one is formaldehyde. This carbon will be converted into formaldehyde. Let's draw another structure. A alkaline system. 9 and 10 carbons are unsaturated, having the olefinic double bond. First we will react with ozone O3, followed by reaction with dimethyl sulfide. So where is the double bond? Here is the olefinic double bond. It will get rupture. We will get this product. You see? So what I'm trying to communicate, what I try to tell you that ozone, whenever it reacts with olefinic double bond, whether in a compound you have one double bond or more than one double bond, so each double bond will rupture and the attached carbon will be converted into carbonyl carbons. Let's study its mechanism. I'm taking a simple alkene and I'm going to react with ozone. What is the structure of the ozone? Ozone normally exists in dipolar form like this. It can also be represented in another canonical form. When this double bond moves over oxygen to stabilize this positive charge, we get another resonance structure of ozone. So normally ozone exists in these two resonating structures. Which one is more stable and predominantly exists? Remember, when opposite charges are closer to each other, that structure is more stable. So normally in your textbooks, ozone is written like this. But a certain percentage of the ozone also exists in this dipolar form. So I'm writing this resonance structure of the ozone. So what happens in the first step? That we know that this olefinic double bond can act as a nucleophile. So this double bond attacks on this electron deficient oxygen through this carbon, and this carbon becomes electron deficient, or it contains positive charge stores, and this oxide it attacks on this carbon, so we get a cyclic transition state. Rather, it's an intermediate. It's called malozonide. Malozonide. It's a five-member intermediate. In the next step, this carbon-carbon single bond it ruptures and this bond moves over here, and this bond moves on this oxygen. This oxygen will get negative charge because this bond moves over here between carbon oxygen double bond. This carbon will get positive charge. This oxygen is getting negative and this is getting positive charge, and we get this carbon oxygen double bond. I hope you would understand this easily. What happens in the next step? For the simplicity I draw this molecule like this. It's the same, just I have reversed its direction. Now oxygen is pointing towards left, and actually this carbonyl group is polar. Oxygen being more electronegative, it's getting partial negative charge, and this is electrophilic center, it has positive charge. So this oxide attacks over here and this bond moves over here. We get another intermediate that is called ozonide. This is ozonide. So whenever ozone reacts with alkene, we get an intermediate called ozonide. So this is the first step. In the second step, we use a reducing agent, that is dimethyl sulfide. And that dimethyl sulfide actually ruptures this ozonide into carbonyl compounds. How? Let's I am writing their structures. This is the same ozonide and dimethyl sulfide is going to react. The sulfur attacks on this oxygen, and this cyclic ozonide, it ruptures, this ring ruptures like this bond moves over here making carbon oxygen double bond. This bond moves over here making this carbon oxygen double bond, and this bond moves over here. So sulfur makes two bonds with oxygen, the first with oxygen and the second with this oxygen. So we get carbonyl compound and dimethyl sulfoxide. It's DMSO, dimethyl sulfoxide. I repeat here again, this dimethyl sulfide, it reduces or ruptures this ozonide. How? This lone pair attacks on this oxygen making a bond with oxygen, and oxygen is getting positive charge. This bond moves over here making carbon double bond oxygen. This bond moves over here making carbon double bond oxygen, and this bond that was initially present with carbon oxygen, it ruptures and oxygen moves makes a new bond with sulfur. So sulfur makes two bond with this oxygen, and we get carbonyl compound from here, another from here. So we are getting the 2 moles of this carbonyl compound. Actually our starting molecules was a symmetrical one, so we are having now two molecules of the same compound. So DMS, the dimethyl sulfide, it has oxidized into DMSO, so it means that it has reduced or ruptured this structure. So initially in your starting compound no oxygen was present, but in your final compounds you are having oxidized molecules. I hope in your previous classes you have already studied this ozonolysis reaction. Let's discuss few specific examples of where this ozonolysis have occurred. Ozone in the first step, and the second in the second step dimethyl sulfide will be used. Now what will be the product of this reaction? So you should recognize where is the double bond that is going to break down into carbonyl compound. So in this structure, this carbon carbon double bond will be ruptured using ozone, and this, and every carbon that is doubly bonded carbon, it will convert into carbonyl carbon. So you will get these products, and this carbon will be converted into another carbonyl carbon. So we will get, uh, are these two compounds are similar or are the same or the different? They are the same because the starting molecule was symmetrical, so you will get the 2 moles of the same compound. So this is our starting compound. Now we are going to react with the ozone followed by the reduction. What will be the product? So you should recognize where is the double bond. Here is the double bond. It will get ruptured and you will get this product, cyclopentanone. And since it's a symmetrical molecule, so you will get 2 moles of the cyclopentanone. Let's discuss another example. It's norbornene, substituted norbornene. We are going to react it with first ozone followed by reduction using zinc HCl. What will be the product? This double bond will rupture, this carbon will be converted into carbonyl carbon, and this one will be carbonyl carbon. So you will get this compound. Let's discuss another example. What will be the product? So I am leaving for you these two examples. Try by yourself and write down the products and send me the answers on WhatsApp. So I will be definitely I will understand that whether you have got a certain idea of the ozone analysis or not. So this was actually our short lecture upon the ozone analysis of the alkene. So thank you very much.